Welcome to the second madrich, second explanation for Targil for problem set number 1 for the lab in computer architecture. I'm going to explain now what to do, how to start the problem 1.2. In other words, lab 1, section 2. Now here you're supposed to make a loop where you accept numbers from the user and make and calculate the total of all the numbers that he enters, ignoring numbers that are outside of a range. And the range is 99 and negative 99. So in other words, 99 would be acceptable, about 100 would be out of the range if you'd ignore that. So this program is going to use input-output from the user. So you're going to have to use system calls. So let's start with a system call. First of all, we don't have any array in this program, so we don't need to make a data section. We can just write .txt and say we're just starting our code. Truth is, you don't have to write txt. If you don't write anything, it assumes that it's a code, not data. So the first thing we want to do is, oh, actually, I changed my mind. We do need an array because we want to be polite and we want to print out to the screen something like, please enter a number. So we need .data, and let's have something like, let's call it input message, and we'll call it dot. We'll make it of type ASCII Z, and the Z means that it's going to put a 0 at the end of it. And we can write simply enter a number less than 100 and more than minus 100. Okay, so there we have our array. And we might want another total. We might want to print out the total is. So let's say output message, and we'll say also ASCII, because these are letters, and we want the null at the end. Sum is, and we might want to put a new line. So let's just do like that. \n means a new line. So now if we type in n, it will print an n, but \n means a new line. So now we have our message, and let's start out with printing a message to the screen. So we need to use system calls. Now, to use a system call, we need a list of what the system calls are, and I have it on my video on my slides, but let's this is a second. Let's type MIPS syscalls, and here. Sorry about the screen. I tried to make it. So we need a list. Here we go. Service. So we want to print an integer? No. We want to read a string? No. We want to print a string. So that's 4 in V0. And what string do we print? Well, A0 will point to the string we want to print. So print string is 4. So let's go back to where we were, and let's type load address of into where? Into register A0, because that's where it needs to be if we're going to print it. And we want to say we want to say, sorry, which array we want to print. We want to print the first one, or enter array. So input message. Now what that's going to do is it's going to take the address, the location of this in memory, and put it into A0. So now we can do our syscall. Well, we need to put into VFS the value 4. That's what we saw on the table. And then if we write syscall, it will print it. So let's try if that works. Now, it doesn't let us print because, see, it's gray because I didn't save it. So if I go save and did I make it? No. Here, I'm going to save it in a special place. Here. And I'm going to call it MIPS 1.2.asm. ASM is for assembler, save, and I've saved it. Now if I try to run it, I can. And I run it, well, I compile it actually, and we see that, okay, it turned our syscall is a syscall, it turned our LA is a pseudo command. Also our LI is a pseudo command because it changed it to add I. Those are the two pseudo commands we let you use. Now let's run it. And I see it typed here, enter a number less than 100 and more 10 minus 100. I must have made a typo there. Okay, no problem. So the message printed. Now, just for the sake of understanding, let's try writing syscall again and see what happens. Compile or assemble and run it. And now if I scroll up here, I see that it prints, well, we don't see print a number less and more than 100, less than it printed twice. Enter a number less than 100 and more than minus 100. Enter a number, here if I do clear, and if I do again run, we see that it printed twice. Enter a number, no new line because I didn't put a new line at the end. So syscall is what actually prints. Everything else just sets it up. So I only want it once. Now I need to get the number. So in order to get the number, I need a different syscall. So what syscall do I need? Let's go back here. I need to read an integer 5. That means in V0, I have to have a 5. And V0 will contain the integer that I read. So if I go back here and I do LI $V0, and I'm going to overwrite the 4 with a 5. And now again, I'll do syscall. And if I compile it and run it, it says enter a number, and it waits for me. And I type, let's say, 18. Enter. Now, what's interesting is to look at V0 here, and we see 12. Well, what's 12? 12 is hexadecimal. Well, the 1 means 16, so plus 2 is 18. That's my 18. Another thing to look at that's interesting is what's in A0. A0 is 10,010,000. Why? Because that's where all arrays start. That's where the first array, I should say, starts. That's the beginning of the data segment, 10,010,000. And if you look over here, well, I made it very small, but it's 10,010,000. This is the address of the first value in the array. That's what the data segment is. Okay, so we've already got the first part. We may want to fix up this string over here. Less and more than, and we may want to put a space here, or 2 spaces, just so that we see where the number ends. Okay. And now we have received our first number, and it's in V0. Now we're going to need another number, another variable to contain the sum that we want to make. So for example, I might put this value into a sum number. But before I do that, I want to make sure it's in the range. And for that, I need to show you two commands. There's SLT, and there's SLTI. Now let's say I wanted to say, is my number less than 0? So I could say like this. Is $V0 less than register 0? Now, if it is, so now I need to have one more variable over here, T1, for example. So what this is saying is, if register V0, which is whatever number he typed, because that's what I got in my system call, is less than register 0. Register 0 is always 0. You see over here, registered number 0 is also called name 0, also number 0. But its value is also 0. Well, all the registers in the beginning are 0. But register 0 is unique in that it stays 0. These ones can change. These ones, for now, I could have theoretically used any register because they're all 0. But I'll use 0 because that's the classic one to use. And it should stay 0. So if this is less than 0, which means it's -1, -2, -3, then T1 will get the value 1. Set, SLT, set if it's less than whatever the other register is. Set less than, SLT, set less than. So this will be set to 1 if it's less than, if this is less than this. If it's not, for example, if V0 is 0, then this, or 1, or 2, or 3, then this T1 will be not 1, it'll be 0. I can also do set less than I, where I is the immediate value. So I could do, for example, like this. $T2, set it if $V0 is less than 10. And then I can write a number here. Now I cannot switch the order. I cannot write 10. I cannot write like that because that's not the order. The order is variable is a register number. So that could cause a little problem, but you can always work around it. If you just think a little bit, you'll always be able to get what you want. So this is going to set this to 1 if it's less than 0. Now I can do something like this. I can do branch not equal. For example, I can say go to some place if, I don't know, if I can do anything here, right? I can say if if $T1 is not equal to, I have to have a register here. Must be a register. If I want to do a number, I'm going to have to store the number in the register first. But I'll just use 0. 0. If this register is not equal to 0, then that means that over here, it was not. If it's not equal to 0, it must be 1, which means V0 is less than 0. Then go to some place, place. And I have to have a place, so let's say I'll go to here, place. So if, I mean, I'm not trying to solve the problem because I want you to solve the problem, but I am showing you the concepts. If this is less than 0, if the result that I got, I compared this one to this one, and the result of that comparison, true or false, essentially, that true or false is in T1. So then I can check if it's not equal to false, which means it is true, means it is 1, then that means it is less than 0, then go back and get a new number. Otherwise it's going to do the next line, and the next line could be, for example, add, And I could say my sum, for example, $T0, I could decide that T0 is my sum. I could decide that T7 is my sum. But now it starts off T0 as 0, so I don't have to do anything to it. T0 equals whatever it was plus the new value that I got, $V0. And then I can jump unconditionally back to place if I want, for example. Because we have to have some way to end. Sorry, like that. So there you go. That's a pretty good introduction for what you need to do. You can use SLT, SLTI. Those are the only two you should be using. There's no, you might think set greater than. There's no set greater than. There's no SGT. And you might think branch less than. There is no branch less than either. There is a pseudo command BLT, branch less than, but we're not allowed to use that. There is a branch not equal to 0, but that's not going to help us here. But I want you to use the SLT and the SLTI, or one or the other, or both, however you want. And that should be enough to help you do exercise 1.2, where you're supposed to accept a number between a range of minus 99 to plus 99 inclusive. Any of those numbers are valid. Every other number should just be ignored. And the sum should keep going until the person puts in a 0. When he puts in a 0, then that means the end. And then you should print out the sum is, and then the number. You'll have to look up the syscall for printing an integer, just like I did. But I already showed you how to print a string. Okay, guys, good luck.